Section 3.2, Example 7. Okay, so let's take a look at some characteristics of log functions written in the form f of x equals log base b of x. First, we need to understand that the domain of the function will be all real numbers that are positive. So everything from 0 to positive infinity, non-inclusive. Okay, the range of that same function will be all real numbers from negative infinity to positive infinity. Now, the graphs of the functions in the form of f of x equals log base b of x will always go through 1, 0. Because stop and think about it. If you substitute in a 1 for x, log base b of 1 equals 0, which means the x-intercept is 1, and there's going to be no y-intercept. Now, if b, the base, is greater than 1, then the graph goes up to the right and is increasing. So something like this. If the base is a number more than 0 but less than 1, then the graph goes down to the right and is decreasing, maybe something like this, a little more so. And then finally, the graph of the function approaches but will not touch the y-axis. So that means the y-axis is a vertical asymptote of the function. Okay, so we just talked about f of x, or y equals log base b of x. And if we write that in exponential form, that's b raised to the y power equals x. Now it's inverse in exponential form. Remember, now you just exchange the x and the y, would be y equals b to the x. So when we talk about exponential functions, their domain and ranges are going to be like the exact opposite of what we just talked about on the log functions, because they're inverses of each other. So if it's in exponential form, then the domain is going to be all real numbers, and the range is going to be just the positive real numbers. And just something really important to remember, the domain of a log function in this form, f of x equals log base b of x, is going to be all x's that satisfy g of x is greater than 0. So in example 7, we have a log function, and we're asked to find the domain of this function, f of x equals log base 4 of x minus 5. Now, it's really important to note, there's not an x here. So, whereas before we said the domain had to be all x's greater than 0, in this instance, we have to find what satisfies x minus 5 is greater than 0 to find the domain. So x minus 5 greater than 0, add 5 to both sides. X has to be something greater than 5 to satisfy the domain. So the domain is going to be from 5, not including 5, to positive infinity. And I've gone ahead and given you here the graph of the function f of x equals log base 4 of x minus 5. As you can see, now we said the domain was going to be from 5, not including 5, to positive infinity. So those are all the possible x's. And notice that x can never be 5. You've got a vertical asymptote actually here at x equals 5. And also in an earlier slide, we were talking about the base and what happens to the graph. This base is 4, and so we said earlier when b was greater than 1, which 4 certainly is, that the graph is increasing to the right. And this is certainly, as you go further and further right, increasing. Okay, so there you go.